group of examples, we actually are given the zeros and some additional information, and we want to work backwards and find the original function. So if we know the zeros, let's start with that. So in this first example, we have the 0 of 2, -3, and 5. So what that means is that I have three equations: x equals 2, x equals -3, and x equals 5. Now working backwards, this tells us what it factored as to give us zeros. Well, then we need these to be 0 to actually figure out what the zeros were when we set them equal to 0. So, well, we'll subtract 2 from both sides on the first one, which will give us x minus 2 equals 0. We will add 3 to both sides on the other one, which will give us x plus 3 equals 0. And then we'll subtract 5 from both sides on the last one, which will give us x minus 5 equals 0, which tells us for our zeros how our original function factored. It factored into 3 pieces: an x minus 2, an x plus 3, and an x minus 5. So what that now gives us is that our original function f of x factored out as x minus 2, x plus 3, and x minus 5. Now there's one piece that we haven't used, which is this point. That's going to get used to figure out what the actual leading coefficient, our a, is. So we're going to find our a by plugging in this point. Now keep in mind that the point has an x that's inside here, and then what's coming out is your y value. So this translates to the point 3, 6 with an x and a y that we can plug in. That means for all of our x's here, we can go ahead and plug in 3. And for our y, which is this f of x, remember y and f of x mean the same thing, we can plug in a 6. Which leaves us with, if we go ahead and carry everything down, the only thing missing and not filled in would be the a, which means that I can find that now. So let's go ahead and carry everything down, and let's solve for a. And again, we plugged in 3 for x. Well, if we're going to solve for a, order of operations says that we need to do our parentheses first, which means we need to simplify all these parentheses. So we need to simplify each of these 3 sets of parentheses. So let's go ahead and do that. The first one is 3 minus 2, which will give us 1. The next one is 3 plus 3, which will give us 6. And the last one here is 3 minus 5, which will give us -2. So all we have to do now is to get rid of the parentheses. The parentheses tell us that all of these constants need to get multiplied together. So what that'll be is a 1 times 6 is 6, times a -2 is -12. That I can actually now put in front of the a. And then solving for a, the last step would be to divide both sides by the -12, which would give us that a now is equal to -6/12, which does reduce. They're both divisible by 6. So if I divide both by a 6 to reduce it, that will give me a -1/2 as my a. Now once you have a, you can go back to the beginning where you have your equation and plug in your a. So that's what we're going to do, is now we've got our function f of x equals, we have our a now, which is -1/2. And then we have our 3 factors, which were x minus 2, x plus 3, and x minus 5. And now what we've made sure is that it has the zeros 2, -3, and 5, and it also passes through the point that they wanted. So this is our final answer for our function that they requested. Problem B is very similar to problem A, but we're going to start making things a tiny bit more complicated when we start mentioning multiplicity. So in this next one, we'll start with our zeros first. So we'll start out with, first of all, we have a 0 of x equals -4, a 0 of 0, and be careful that 0 of 0 has a multiplicity of 2. So the first 0 of -4, if we write it out as an equation, x equals -4, to figure out what was going to be originally part of the function that was factored, is you'd actually have to set it equal to 0. So you'd actually have to move the 4 over back by adding 4 to both sides. And then what that does is gives you that the factor that would have equaled 0 would be x plus 4 equals 0. So that's going to be the first part of our function f of x, is the factor x plus 4. The second part is going to come from the 0 of 0. So we'll start out with x equals 0. And to go ahead and make that equal to 0, it's already equal to 0. So the factor that is going to be a part of our f of x is x. But be careful, because it's got a multiplicity of 2. It means it needs to be raised to the second power. So I'm going to take this x and actually include it as to the second power because it's got a multiplicity of 2. So that means I'm also going to have an x squared as a factor. I'm going to put that out in front. The only other thing that we need to find is our a, is our constant that's out in front of everything. And that's where our point comes in, that f of -1 equals -6. And this can be translated into the point, because here's our x inside and our y outside, turns in the point -1, -6, that we can plug in wherever there's an x. And the f of x, remember, is the same thing as a y, so we can plug in our values for x and y. So what happens is the y gets replaced with the -6 equals, and we've got the a is what we're trying to find. Then the x is going to get replaced with the -1. But notice that first x is again squared because it had multiplicity of 2. Then we have our -1 for the other x plus 4. And so now what? Now we need to solve this thing for a. We need to follow order of operations. So we need to do what's inside the parentheses first, and that would be the -1 plus 4, which will give us a +3. And be careful, so we'll have a +3. Then what needs to happen next is we need to do our exponents next according to order of operations. So -1 squared is actually going to be -1 times -1, which is going to give us a +1. Now's when we can finally do our multiplication. We can do our 1 times 3, which is going to give us 3. That's attached to our a here. And we've got our -6. Last thing that we'll do here is divide both sides by 3 to get our a. Well, notice what happens is that you'll get that a equals -6 divided by 3 is -2. Now what do we do with our a? Now we're going to take our a and go back to our original function and plug it back in. So we're going to go back to our original and plug it back in for a. So that's going to give us our final function f of x of -2 is getting plugged in for a, and then our factors, which were x squared and x plus 4. And what this does is make sure that we have our 0 of 0 that has multiplicity 2, our 0 at -4 with multiplicity of 1, and it does pass through the point that we wanted because of the -2 that we chose for a. And we're done now.